Hello everyone, in this video we're gonna learn how to solve these challenging integrals. Alright, before we're gonna start, go ahead pause the video and give you a try. Alright, let's get started. The integral from 0 to pi over 2 of cosine s plus cosine square of s over 1 plus sine s plus cosine of s ds. Alright, so when you see the upper bound and the lower bound like this, you're gonna think about the King's rule. Alright, so we have the formula, the integral from a to b f of s ds equals integral from a to b of f of a plus b minus s ds. Alright, to prove this formula is very easy. Alright, so I'm gonna prove this formula using this problem right here. So I'm gonna let u equals a, which means 0, right? B, which means pi over 2, right? So it could be 0 plus pi over 2 minus s. It could be pi over 2 minus s, right? Now I'm going to take the derivative both sides. So I have du equals negative ds, right? Or ds equals negative du, right? So I put negative side right here, right? Now I need to change the lower bound and upper bound, right? So when s equals 0 and s equals pi over 2, you have u equals pi over 2 and u equals 0, right? And then the integral right here, I call this the I. So I becomes the integral from pi over 2 to 0. Put the negative side right here because you have ds equal negative du, right? So I put du right here, right? Now the guy inside here, cosine of s, it becomes cosine of pi over 2 minus u, right? Because s equals pi over 2 minus u, right? Plus cosine square of pi over 2 minus u over 1 plus sine pi over 2 minus u plus cosine of pi over 2 minus u, right? I need to flip the powers right here. Then I'm going to change this one to positive. So it turns out to be the integral from 0 to pi over 2, right? Now keep in mind you have the formula sine of pi over 2 minus u equals cosine u, because in this situation sine and cosine are complementary angles, right? Similar, cosine of pi over 2 minus u equals sine u. So keep that in mind. So this guy turns out to be sine u plus sine square of u over 1 plus cosine u plus sine u, right? Du, right? So since this variable right here agree with this variable, right? So I just replace this one with s, right? So it turns out to be, so I'm gonna add I both sides, right? So it turns out to be 2i equals the integral from 0 to pi over 2. I just rewrite this one, it could be, and then I'm gonna add another I, which means the original one right here, right? So it could be, now look at the bottom right here, they have the same denominator, so I add the top, right? So sine s plus cosine s, it could be right here, sine s plus cosine s, right? Now sine square of s plus cosine square of s, it could be 1, right? So I put 1 right here. Bottom should be 1 plus sine s plus cosine s. So I need to rewrite the integral from 0 to pi over 2. I put the s right here, right? Alright, so this guy right here cancel out, right? So I have 2i equals the integral from 0 to pi over 2 of ds, right? So it turns out to be s evaluated from 0 to pi over 2, right? So it could be pi over 2. Now I need to divide both sides by 2, so I equals pi over 4, right? And this one is the final answer. So I just use this problem to prove this formula, right? So if you see similar problem like this, you just apply the formula right here directly. You get the answer. quickly, right? It's just like 30 seconds. If you have another way to solve this problem, please leave a comment and it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in